Hello everyone, welcome back. And now we'll be doing lecture number 11's part 2, which is hardness. In the previous lecture, we studied about alkalinity. So, whatever was important for you to understand, I explained each and everything in that lecture. Please go and see that before coming to the hardness one, because the things which I explained in that will also be useful for calculating the hardness. So yeah, so the question that comes in our mind when we hear about hardness is, what is hardness? So the question that is, what is hardness? So hardness is caused by the presence of calcium and magnesium ions. In other words, I can say it is due to the presence of multivalent cations. Mostly it is calcium and magnesium, but if there are present other ions as well, for example, and that should be of multivalent. So, for example, if we have the presence of aluminum, so this will also create hardness because it's multivalent cation, right? So, due to the presence of calcium and magnesium are the major ones, right? But we have aluminum, we have ferric, 2 plus, 3 plus, right? We have iron, we have manganese, we have lead, and then we have SN. So these are the minor ones. These will also create the hardness. So for example, like we have so this is what we call hardness. So hardness is calcium and magnesium ions present into the water. So this is what hardness is. Now we go to the next is effects of hardness. So due to the hardness, the soap does not lather, and scaling will be there into the pipe, and the boiler will also show some issues in that, right? And we have in the next one we have types of hardness. So there are two types of hardness. One is a temporary hardness, which is carbonate hardness, and permanent hardness, which is non-carbonate hardness. So the carbonate hardness is the hardness which is due to the carbonate and bicarbonate. So CH is due to, so the hardness is of two types, carbonate hardness and non-carbonate hardness. Carbonate hardness is due to CO3 2 minus ions and HCO3 minus ions, right? So the compounds which are multivalent cations which are making compound with CO3 2 minus and HCO3 minus will give carbonate hardness. And for non-carbonate hardness, other than these carbonate ones, for example, we have chloride, and then we have sulfate, and then we have nitrate, right? So these are the ions. With these, if there is any multivalent cations who is making compound, so these will create non-carbonate hardness. Okay, so uh, carbonate hardness is the temporary one. We'll be able to remove it just by boiling, right? So we will be able to remove this by boiling, but permanent hardness cannot be removed by boiling, right? So not removed by boiling. Okay, so let's have some example, like we have CaHCO3 2. So this will create carbonate hardness, right? And let's say we have MgCO3, this will create carbonate hardness, right? And then we have CaCO3, this will not create any kind of hardness because it precipitates. Okay, so it will precipitate and settle down, it will not create any kind of hardness. And then we have Na2CO3, will it create hardness? No. Why? Because Na is a monovalent cation, right? Univalent cation we can say. So this will not create any kind of hardness. This thing we need to understand. And then calcium CaSO4, will it create hardness? Yes. And which type of? Non-carbonate, because these are SO4 is not carbonate, right? And then we have AgNO3. Will it create hardness? No, because Ag is single valent. Okay, so this is Ag2NO3. So this is what the thing works here. Nitrate is single, so AgNO3. Okay, so this is because silver is also univalent cation. Yeah, so this is how we understand which is carbonate hardness, which is non-carbonate hardness, and what are the univalent cations, what are multivalent cations. Right, now next we have for we'll see one example now. Okay, so let's see what's I have planned. Okay, so I have planned in the next thing, which is temporary hardness caused by uh, carbonate and bicarbonates. Okay, so this is one of the example. So temporary hardness is caused by carbonate and bicarbonate, and that's basically carbonate hardness. And then we have permanent hardness. So this is caused by, I already explained you, sulfate, chloride, these kind of ions which are not the carbonate ones, so it will create permanent hardness, right? And now we have uh, total hardness. Let's just calculate one question. So in that only I'll be putting the example. Okay, so for example, we have been given a water sample, right? Now in this water sample we have 120 milligram per liter of calcium. Okay, and then we are also given that there is 96 milligram per liter of magnesium, and also given there is 27 milligram per liter of aluminum, right? Now I have to calculate the total hardness. So what is total hardness? Okay, so for the total hardness we have a formula to calculate the hardness. So for total hardness, if it all the multivalent cations which are present into the sample, we'll be taking that concentration of that in milligram per liter, and in that we will be multiplying by equivalent weight, because hardness is also given as the as equivalent to CaCO3. So equivalent weight of CaCO3 upon your equivalent weight of Ca2. Okay, so basically, and then we'll be adding magnesium, and so if I want to write it in general form, so the calcium ion plus magnesium ion plus aluminum ion plus whatever is there, the multivalents. Okay, so we'll be putting that in milligram per liter, and then we'll be multiplying it by equivalent weight of CaCO3 and divided by equivalent weight of your iron, whichever will be putting that. So I should write this equivalent weight of calcium, and then equivalent weight of magnesium, then EW of aluminum, right? So I will remove this from here because every ion will have its different equivalent weight, right? But equivalent weight of calcium carbonate is common one, so I can write that. So this is the formula that works. Okay, now if I want to calculate this total hardness, so it is 120 milligram per liter divided by what is the equivalent weight of calcium. Total weight is 40 and then equivalent weight is 20, right? And then I'll be multiplying by 50. Magnesium is 96, so its weight is 24 and that 2 divided by 20, so it will be 12 into 50, plus aluminium is 27 and its weight is also 27 and divided by 3 it will be 9 and into 50. So if I calculate it, I get the value as 850 milligram per liter. So this is the total hardness of this water sample. And yeah, so this is how you will calculate the total hardness. And I with this I want to just tell that the limits which are acceptable, so I'll mention that with green. So limits for hardness is, so acceptable limit is 200 milligram per liter as CaCO3, and the rejection limit is 600 milligram per liter as CaCO3. So these are the limits to calculate the total hardness. So if it is under 200, the water is fit for use, and if like we can use it if it is more than 200, but if it goes beyond 600 then we need to reject it. There's no other things to uh, like understand. Now we have uh, then now let's move on to the next thing, which is measurement of hardness. So we have, for measuring the hardness, we have the method, we call it as EDTA titration. So this titration is also known as complexometric titration. So we'll be also writing it complexometric titration. So uh, just by doing the titration, then only you can calculate the hardness. So this titration of by EDTA will be used as titrant. So the titrant will be EDTA. Titrant is the one with which we'll be titrating our water sample. So EDTA is the titrant, and the titration is known as complexometric titration. So now what we are going to do is, and then there is one indicator, just like in alkalinity, titrant was HCl and indicators were phenolphthalein and methyl orange depending on pH. In this, titrant is EDTA for hardness titration, and indicator that we are using is Eriochrome Black T. Okay, so the full form of EBT is Eriochrome Black T, and EDTA is ethylene diamine tetraacetylene. Okay, so EDTA is this. Now, so the full form of EDTA is ethylene diamine tetraacetic acid. And the formula of EDTA, I'll just, so the indicator is EBT, Eriochrome Black T, and the formula of EDTA, if I'll just make the formula. So it is something like we have, let's choose another color. Let's have this color. So we have two carbon molecules in the center with single bond, and then we have hydrogen and hydrogen, and here it will be connected with nitrogen. Here also will be connected with nitrogen, and then we'll be having CH2 and again CH2. Here also CH2, 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 and then from here we have connected carbon and then OH and then double bond O. Same carbon, OH, double bond O. Here also carbon, OH, double bond O, carbon, OH, double bond O. So here we can see how many carbon we have: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the formula is C10, and if I want to calculate H, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So H is 16. How many nitrogens are there? So nitrogen is only 2, N2. And how many oxygens are there? 1, 2, 3, 4, 5, 6, 7, 8. So O8. Okay. So this is ethylene diamine tetraacetic acid. So this is the formula, and this is the structure. Now the property of EDTA is it's an chelating agent. So I'll be writing chelating agent. Now what is the chelating agent? Chelating agent, chelating means claw. Claw means it's just binding the things. So EDTA works as a very strong bond for metals. So it chelates metal complex. So it creates metal complex. So calcium and magnesium are metals, right? So from metal only hardness is coming. So calcium and magnesium are the metals, and what EDTA does, it creates a very strong bond with calcium and magnesium. Okay, so what's the process here in hardness measurement titration? What we are doing is we have taken a water sample. Okay, so we have water sample, and if there are uh, and then EBT is indicator, right? We'll be taking a pinch of EBT and we will add that into the water sample. Okay, when if your water sample is not having any calcium or magnesium ions, okay, EBT will create a blue color, right? So EBT will create a blue color when calcium, magnesium are not there. Okay, so this is original color of EBT. But when calcium and magnesium ions are present in water, then what happens that EBT creates complexes with calcium and magnesium, and that complex color is red. So the color is red when it creates calcium magnesium complex. All right. So now if the water is having a hardness, that means it is having calcium and magnesium ions, so that EBT will create red color complex. Okay, now what we are doing, so we have a sample in our conical flask which is of red color. Now EDTA is filled into the uh, burette. Okay, so EDTA solution is filled into the burette. Now what we will be doing, we will just titrate. We will start titrating that. We will be mixing EDTA drop by drop. Now what happens? I have told that EDTA is chelating agent. So it has the strongest affinity to attract metal ions. So, and the metal ions has already created bond with EBT. Now, EBT, what EBT will do, just because EDTA is stronger one, metal ions will leave EBT and will start creating complex with EDTA. Okay, so EBT, more the EDTA will be adding, more the EBT complex calcium and magnesium will run to the EDTA and it will leave EBT. So when EBT is left alone, there is no calcium and magnesium ions mixed in a that are making complex with EBT. So the EBT's original color will come out. What is the original color? That is blue, right? So original blue color will come out. So when all the calcium and magnesium has made bond with EDTA, there will not be anything left for EBT to make complex, because EDTA is the stronger one. Every calcium magnesium ion will leave EBT and the original color of EBT, which is blue, will pop up. So when the original color of EBT comes out, so we can say the titration is finished. Okay, so with that we can say the titration is finished. So this is how hardness titration is done. Okay, now yeah, so this is what the titration thing is there. So I hope you understood what is the use of EDTA, what's the use of EBT. EBT is an indicator, EDTA is a titrant. Okay, and with that EDTA will make the stronger complex, and once all the calcium and magnesium are done with EDTA, they have made complexes. EBT's original color will come out, and with this we can say that end point of hardness titration has come. Okay, so this is how we calculate the hardness. We do the hardness titration basically into the lab. Okay, so now next we have, okay, so EDTA concept I have already explained you. Now we have a topic which is hardness versus alkalinity. Basically I should do hardness and alkalinity versus or and, so whatever we can do. See, so I am writing here calcium, magnesium, Na plus, CO3 2 minus, SCO3 minus. Okay, so alkalinity can be there due to all this. Hardness is only because of multivalent cations, right? But alkalinity can also be generated due to single valent uh, cations also. So this is for alkalinity. But when it comes to hardness, there should be multivalent. That means calcium and magnesium only. Okay, so this is for hardness. And yeah, and basically we have this carbonate and bicarbonate will create carbonate hardness, right? And the very first case, that if Na alkalinity is present. So if we have Na alkalinity, what is the meaning of Na alkalinity? Something like we have Na2CO3, right? And then we have NaHCO3. These will not create hardness because this is single valent cation, right? But it will create alkalinity, right? So if it's not present, the first case is it's absent. So if these things are absent, then we can say that alkalinity is only due to carbonate hardness. Okay, and we know that total hardness is nothing but carbonate hardness plus non-carbonate hardness. So carbonate hardness is alkalinity. Okay, carbonate hardness is alkalinity plus non-carbonate hardness. So from here I can say that total hardness will be equal to will be greater than alkalinity, right? So this is the first case. So yeah, so in conclusion, I can say that Na alkalinity is absent only if we have what? Non-carbonate hardness. Okay, so if non-carbonate hardness is present, then Na alkalinity will not be there. This is the conclusion. This we should remember. So if Na alkalinity is absent, there will be non-carbonate hardness, and if non-carbonate hardness is present, there will be Na alkalinity absent. So this is the thing. Now the second case is if Na alkalinity is present. So if Na alkalinity is present, non-carbonate hardness will be equal to 0. This is from this conclusion. So total hardness will be equal to carbonate hardness, right? So total hardness will be equal to carbonate hardness, and then with this we have one more very important conclusion, which is alkalinity, total hardness, and alkalinity. Out of these two, whichever is minimum, we'll be taking it as carbonate hardness. Out of these two, whichever is minimum, we'll be taking that as carbonate hardness. Total hardness and alkalinity, whichever comes at the minimum one. Okay, so let's understand this with one example. So okay, with this we come to the summary, and before summary, let's do one question. Yeah, so we have something like that. Question is, you have to find total hardness, carbonate hardness, non-carbonate hardness, and alkalinity of the sample. Sample is something like this. We have calcium 40 milligram per liter, and then we have magnesium 48 milligram per liter, and then we have Na. This is 46 milligram per liter, and then we have aluminium, which is 18 milligram per liter, and then we have HCO3 minus, which is 244 milligram per liter, and then we have CSO4 2 minus, which is 96 milligram per liter. Okay, so these things are given, and with this I need to calculate total hardness, carbonate hardness, non-carbonate hardness, and alkalinity. So let's do it. So I can calculate total hardness. That's only due to multivalent cations. So we have calcium, magnesium, aluminium. These are the multivalent cations. So can I do 40 upon it, the equivalent weight of this 20, plus magnesium is 48, so equivalent weight is 12, plus aluminium is 18, equivalent weight is 9, and whole will be multiplied by the equivalent weight of CaCO3, and we'll be getting it this as CaCO3, and the value that comes to be as 400 milligram per liter as CaCO3. I have already calculated this. Okay, so this is total hardness. Now, total alkalinity will be due to HCO3 minus, will be due to CO3 2 minus, will be due to OH minus, and will be due to H plus, right? And yeah, in this sample, the pH is also given as 7. If the pH is 7, then OH minus concentration will be 1 into 10 to the power minus 7. Now you compare. See, OH minus, if pH is 7, OH minus ions are equal to H minus ions. So these two will be cancelling each other. So it's not 0. These two will be cancelling each other. And carbonate hardness is not given in this question. We'll be taking that as 0. So only bicarbonate hardness is present, that is 244. And then we have to multiply it by equivalent weight 50, and then it's 61. So the value comes out to be 200 milligram per liter as CaCO3. Now compare with we see total hardness and total alkalinity. So TH is greater than TA, right? So TA is the minimum one, and the minimum one will be carbonate hardness, right? So the carbonate hardness from here carbonate hardness is nothing but equal to total alkalinity, that is 200 milligram per liter. So I have calculated total hardness. So this is calculated total alkalinity. So this is calculated. So and carbonate hardness is also the total alkalinity calculated, and non-carbonate hardness is nothing but total hardness minus carbonate hardness. So 400 minus 200 will give you 200 milligram per liter. So non-carbonate hardness is also calculated. So if in the question, even if pH was given like this, let's say 8, so this will be 10 to the power minus 8, right? So OH concentration is in 10 to the power minus range. So even and this is 244. So if we are comparing this with OH minus, so OH minus is nothing. So in that case also we can ignore OH minus. In this it's obviously equal to the H plus, and so it cancels out. But if it is not specifically given, the OH minus concentration is very low in neutral water, so we ignore it basically. So this is how we calculate the hardness of the water and all other compounds. So I hope you guys understood this, and with this we have finished our lecture 11 fully with alkalinity and hardness. So thank you.